In this short little note segment, I'm going to explain alternate ways that we can convert from a non-base 10 number to another non-base 10 number when we have what I like to call a common lower base. So here are a few examples of the scenario for which I'm referring to. If I want to go from base 8 to base 2, 9 to base 3, or even base 8 to base 4, since I have a common base 2, a common base 3, and a common base 2, I can easily take the number that is in the higher base and then expand it in terms of more place values for the lower base. So let me show you what I mean by this. If I take a look at this first number, which is in base 8, and I want to go into base 2, remember that one place value in base 8 is essentially going to represent the numbers from 0 to 7. Once I would get to an 8, I would go up to the next place. Well, in base 2, these place values are powers of 2. So in this case, if we think about the different values, this first digit goes from 0 to 7, and all three of these digits represent a number from 0 to 7. So what I can do is I can take every digit in base 8 and replace it with 3 digits of how it would look in base 2. Let me show you what I mean by that. So I'm going to write these numbers a little spaced out just so that I have a little bit more room to work with here. And then I'm going to put 3 dashes under every one value in base 8. And then I'm essentially asking myself, how many 4s, 2s, and 1s do I need to add together to get to the number given? So adding to the number 1, I'm just going to have a 1 here, and then I'll have 0 in the other places. To get a 2, I will see a 1 here in the 2's place, and then a 0 and a 0. To get a 7, that happens when I fill all places. So a 4 plus a 2 plus a 1. A 0, well, that's when I have none. And then a 4 would just be a 1 in the 4's place, and then 0, 2, 0, 4. I mean 0, 2s, and 0, 1s. And so now, the way that I would write this final answer is simply just adding all of these numbers together. And this should remind you, if you've converted from hex to binary before, this is a very similar process, where in hex we replace each single digit with 4 digits in base 2. So this is a similar strategy to that. All right, when I'm converting from base 8 into base 4, what we're going to do is we're going to take every one digit in base 8, and we are going to replace it with 3 digits in base 4. And then what we can do is that we can group all the places in pairs starting from the right. And the reason why we can do this is because of the way that the different powers of 2 work. And so since an 8 is 3 spaces in base 2, a 4 is equivalent to 2 spaces in base 2. So we can essentially take these values and just pair them all up. It's pretty cool how it works. All right, so let me go ahead and let's first space out this number. So I have the 4, 3, 7, 1, 0, 6, 1. And I'm going to replace every singular digit with 3 digits. There we go. Okay, so now what we can do, I'm actually going to draw in a separator just because there are so many dashes and it's really easy to lose your place on something like this. All right, so first I'm going to take every single number that I see here and rewrite it in its base 2 equivalent. So this would be a 0, 0, 1. I'm going to have a 4 and a 2 and a 0, 0, 0, 0, 0, 0, 1. 7 is all 3 of those digits together, a 4 plus 2 plus 1. Here I'm going to have a 2 and a 1, and then a 4, and nothing and nothing. All right, so before you keep going, you want to just do a quick double check, make sure that we didn't make any careless errors, and once we're good, then we can go ahead and we can start pairing the numbers off. All right, I am going to go with teal. So I'm going to pair up these two, skip two, these two, skip two, and just go through and pair up all my values. And in this case, I end up having an extra leftover, and that's fine. It just basically means you want to think of it like if there was a digit in front of it with a place value of 0. And now that I've paired up all the values, I can take them and think about what those two digits together would be in base 4. So this would be a 1, 0, 0 is a 0, 1, 1 would be a 4 plus a 1, or I'm sorry, oh goodness. Okay, so this right here in base 2, this is my 2 and my 1. So this would be a 3, this would be a 0, 2, 0, 3, 3, 1, 0, 1. All right, 1, 0, 1, 3, 3, 0, 2, 0, 3, 0, 1. And that would be my equivalent in, goodness gracious, I'm sorry, I'm writing so many things wrong. My equivalent in base 4. All right, so just to recap, what we did is we took our each digit in base 8 and we expanded it into 3 places for base 2, and then recognizing that 2 digits in base 2 is equivalent to 1 digit in base 4, we were able to take that expansion and group it 2 digits at a time. All right, for this last problem here, we're going to go from base 9 into base 3. And so in this case, if we think about this, 1's digit in base 9 is going to be equivalent to the 3 and 1's digit in base 3. So I'm going to take every one of these numbers and I'm going to replace it with 2 digits. So I'm going to have a 3 and 2 1s, 1 3 and nothing. I'm going to have 2 3s and nothing, and then 2 3s to give me 6 plus 2 1s. So my answer will be 2 2 2 0 1 0 1 2 0 1. The reason why I love this strategy is that it takes all of that complex multiplication, division, subtraction out of the process of switching number bases. It's much, much easier to do as you're working through problems, especially without a calculator and especially given a time crunch. All right, good luck.